So let's begin lesson 4.1. So this time we're starting with exponential functions. So we just finished polynomial functions, and the difference is polynomial functions, the variables are the bases and the exponents are numbers or fractions and stuff like that. With exponential, it's just the opposite. The base will be a number and the exponent will be a variable. So that's the difference. So exponential functions have a variable for exponential, I can't spell this morning, functions. They have a variable as their exponent. Oops. Okay, so they have their variable as an exponent. The standard form is this. It's y equals a times b to the x power. B is the base, and it's also called the growth factor, and if b is greater than 1. And then the y-intercept occurs at 0, a. Okay, so this is going to be your y-intercept. Excuse me. So there's graphing. Don't worry, I moved the fun meter over to red. Graph each function and state the domain, the range, and the horizontal asymptote. An asymptote, it's kind of a fun word to say. It's a line that the function will never ever cross. It's going to get really, really close. So it's a line that the function will get really, really close to, but never cross. Oops, not that. Close to, but never cross. Oh, for Pete's sakes, I can't spell today. Never cross. Okay, so if we're going to graph this one, y equals 5 to the x. So what we're saying, it's really 1 times 5x. So we could also rewrite it as y equals 1 times 5 to the x plus 0. This plus 0 is your horizontal asymptote. Okay, which means that this is never ever going to cross the 0 line, this x line. So our horizontal asymptote is y equals 0, which is this line right here, which is the x-axis. Okay, so that's going to be our asymptote. And now we're going to fill in our table. We're going to have an x, we're going to have a y. And you can pick whichever numbers you like, but I usually pick -1, 0, and 1. Well, 5 to the -1, since it's a negative exponent, it gets moved to the bottom, and this is going to be 1/5. 5 to the 0 power, remember anything to the 0 power is going to be 1. So when we put a 0 in there, we get 1, and when we put a 1 in there, we get 5. So we're going to plot those points. Okay, so we're at 0 and we go up 1. We're at +1, we're going to go up 5. 1, 2, 3, 4, 5. And then when we're at -1, we're really close. We're down like here. Okay, and again, it's going to be this curve. Okay, and it's going to go up. You're going to notice that these are going to go up a lot faster than they do with those, like the square roots and the quadratics, the square roots and the cube root ones. Okay, so the domain, remember the domain is how far left, how far right. Well, this is going to keep going on and on to the left, and this one's going to keep going on and on to the right. So your domain is all reals. But now with the range, we don't want anything lower than 0, so we want all the x's that are going to be greater than or equal to 0, just greater than, because it'll never cross 0. So just greater than 0, my apologies. Okay, because it's never going to cross, because remember that's our asymptote is at 0, so it'll never cross that. All right, let's try letter B. Okay, we're going to add a +0 here, because that +0 is our horizontal asymptote again. Okay, so that's going to be y equals 0, which again is this line here. Okay. And then again, just pick, oops, that should be an x and a y, and I just picked -1, 0, and 1 when it looks like this. So now when we put in -1, we're going to have 1/3 times 3 raised to the -1 power, and we get negative, or 0.1111, all that, and then we can switch that to a fraction, and we get 1/9. Okay, now we're going to do why do I keep saying negative? We're going to do 1/3 times 3 raised to the 0 power, which is 0.333. Change it to a fraction, and we get 1/3. And now when we put 1 in there, so 1 divided by 3 times 3 raised to the 1, we're going to get 1. So when we're at -1, we're at -1/9, so we're like down here. When we're at 0, we're up just a smidge more. And we're at 1, we're here. Okay, so it's going to go like this. It's going to get really, really close and then go up. Okay, that's your graph. Our domain again is all reals because it keeps going on forever to the left and on to the right. And our range, because this is our horizontal asymptote, we want all the x's, all the y's, my apologies, all the y's greater than that. Are you having fun? Mm-hmm. Yep, I know you are. All right, letter C. When you have a fraction raised to an exponent, you can simplify that fraction as 3.5 and x, and then when it's a negative, there's really that -1 out there. Again, we can add that 0, so this is going to be our horizontal asymptote. Okay, so we're going to have our x and our y. We can do -1, 0, and 1. So now we're going to have -1 times 3.5 raised to the -1. We're going to get that really funky number. So hopefully it turns in. So we get -2/7. Alright, then we have -1 times 3.5 raised to the 0. So we get -1. And then we have -1 times 3.5 raised to the 1. So we get -3.5. Alright, so we're going to graph this. Oh, our horizontal asymptote again is 0, so it's this line right here. And that's y equals 0. So when we're at -1, we're at just about a little more than a quarter. When we're at 0, we're at, how about negative though? Because it's -2.7. So when we're at -1, we're down -2/7. When we're at 0, we're down -1, and we're at 1, we're down 3.5. So 1, 2, 3.5. Okay, so this time it's going to swing going down. Okay, because of this negative sign out front, it turns around and it's going to go down. All right, our domain, again, we can go on and on and on forever and ever to the left, and we're going to go on and on together forever to the right. So this is going to be all reals. Now the range, we don't want to go above 0, so we want all the y's less than 0 this time. Okay. Now for this last one, for D, this time we actually have a plus. So this time we have a +1. We don't have to add that +0 because we have this. So this here is going to be our horizontal asymptote. So that's going to be y equals 1. So y equals 1 is this. You can't see that. Let me use my red pen. You're going to use this. This is going to be your asymptote. okay? So it's never going to go below that or above it. Okay, so we're going to take x and y. So normally, when we were doing like this one up here, we did -1, 0, and 1. But this time, we're going to multiply the x's by 2, okay? Because we want to make sure that we've got enough, we got a good graph going on here. Okay, if we use -1, 0, and 1, it's going to be really clumpy, okay? Because we're multiplying this by 2, no, I lied. It's because of this 2. I am so not speaking right. Because we're adding 2 to our exponent, we're going to add, so normally we start with, right, negative, this is our x and our y. We started with -1 and 0 and 1. Well, now for the x's we're going to use, we're going to add 2 to this, to all of these. Okay? I lied, we're subtracting 2. Okay, because we're adding 2 here, we're going to subtract 2, do the opposite to the x's that we normally start with. All right, so normally, let's try that again. You can't even see what I'm writing here. Normally we started with -1, 0, 1. Because we're adding 2 to our x's, okay, that's going to shift our graph over. Okay, and so we want to do the opposite, so we're going to subtract 2 from all of these. So this time we're going to do -3, -2, and -1. Just adding these guys together. So -2 plus -1 is -3. -2 and 0 is -2, and -2 plus 1 is -1. So we're going to put -3 in there instead. Okay, remember that +1 is not in your exponent. So we're going to take 2, how about I turn it on? So 2 times 4 raised to the -3 plus 2 plus 1. So you get 1.5. Okay. And then we're going to do 2 times 4 raised to the 2 plus -2 plus 1 plus 1, enter, and we get 3. Alright, and then we're going to do 2 times 4 raised to the 2 plus -1 plus 1, and we get 9. Okay, so that's what we're going to graph. So when we're at -3, 1, 2, 3, we're going to go up 1.5, so 1.5. When we're at -2, we're going to go up 3, 1, 2, 3. And when we're at -1, we're going to go up 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so notice how much steeper this is than some of these other ones. All right, all of a sudden we go skyrocketing up there. Okay, our domain again is all reals. Our range, we want everything greater than 1. So we want the y's greater than 1. All right, next page. All right, we can use this as exponential growth. Okay, scientists use this a lot when they're doing like growing bacteria and fruit flies and all that fun stuff. Okay, A is the starting amount. It's our y-intercept. The R is the increased percent as a decimal, not as a percentage. Even if it is a decimal with a percentage, you still got to move that decimal over. T is the time in years. And then 1 plus R is the growth factor. oh, it's up here. I didn't have to write that again. 1 plus R is the growth factor. All right, so let's try these couple examples here. In 1970, the population of Madison was about 172,000. From 1970 to 2000, the population grew at an average rate of 0.55%. We're at an exponential growth model where t is the number of years since 1970. All right, so A is our starting amount. So that's the 172,000. R is our rate, but now remember we need to divide this by 100, even though it is a percentage and a decimal, but because there's that percentage sign you need to divide, so you're going to have 0.0055 when you do that. So our R is 0.0055. T is the time in years, but we're going to leave that right now because we're just writing the equation. Okay. So our P, our population, is going to be the 172,000 times 1 plus 0.0055 to the T. Okay. When we add this together, it turns into P equals 172,000, 1.0055 to the T. How about T, not 6? Where did 6 come from? Good lordy. Okay, so this is our final equation that we can use to calculate. So now here it's asking about how many people lived in Madison in 1990. Okay, so our time is from 1990 minus the 1970, because 1970 was our starting year. So our T is 20. So we're going to take that and sub it in for T. So our population is 172,000, I don't know why I'm having such a hard time saying that number, times 1.0055 to the 20. Okay, so we're just going to put that in our handy dandy calculator. 17200 times 1.0055, close up the parentheses, raised to the 20, and it's about, so P is 191,941.969. Okay, can we have 0.969 people? No, just round that up. Okay, so it's going to be about, about 191,942 people. Okay. So that's how you do one for a population. Now we're going to do this, we can use the same type of thing for compound interest. Okay, this is when you put your money in the bank and they're going to give you interest earned on the amount of money you put in and any interest you previously earned. Okay, and so they do this with savings accounts and other things like that. So P is the principal, that's our starting amount. N is the number of compoundings per year. Okay, how many times is interest paid? Okay, R is the rate, again as a decimal, and T is the number of years. Now for N, okay, if they say quarterly, that means it's earned 4 times. Okay, if it says obviously monthly, that would be 12. Biannually, I can't spell the word. That would be 2 times. Okay, but those are kind of the most common ones, especially quarterly. All right, so here on example number 3, we deposit $5,500 in an account that pays 3.6% annual interest. find the balance after 2 years if the interest is compounded with the given frequency. Okay, so semi-annually, okay, that's the same as biannually. All right, so our P, our starting amount was the $5,500. Our rate for this one is going to be, we have to divide this by 100. Why can't I do that in my head today? So our rate is going to be 0.036. For this one, our N is going to be semi-annually, so it's going to be 2. Okay, and over here, monthly, our N is going to be 12. P and R are going to be the same thing. Our T is 2. So we're going to take A equals P, and then 1 plus R divided by N to the N times T. So our amount that we're going to have after 2 years is going to be 5,500 times 1 plus our rate, which is 0.036 divided by 2, and then we take it 2 times 2. I always do this piece first. 1 plus, you can't see what I'm doing. I go 0.036 divided by 2, then I add 1, and so this is going to be, and you can't see what I'm writing, 5,500 times 1.018 to the 4th power. So now I'm going to do 5500 in parentheses 1.018, close it up, raised to the 4th. So this is going to equal 5906.82. Okay, so, and that's in dollars. So the amount is going to be 5906.2. So they made like $400. All right, the only thing we need to change is our N. So again, our amount is going to be 5,500. 1 plus 0.036, but now we're going to change that 2 to a 12, and then we're going to have 2 times 12 up here. Okay, so we're going to have 5,500, and then 0.036 divided by 12 plus 1. Now we end up with 1.003 to the 24th. So our amount is going to be 5,500, parentheses 1.003, raised to the 24th. 5909.97. And that's going to be dollars. Okay, so your homework assignment is page 232 to 233, number 1 through 27, the odds, and 35 through 38, all of them. Let me know if you have any questions.